Well, thanks, James, for having me. This is Linux OS Fundamentals for the PowerShell expert. That would be you guys. I'm Anthony Centino. I'm a consultant and trainer and founder of Centino Systems, where I specialize in system architecture and performance. So I like to design systems and make things go fast. I'm a data platform MVP, Linux Foundation certified engineer, and a friend of Redgate, which is a SQL Server Community Award. I do have my contact information here for you guys. There's my email. So if you have any questions or want to follow up with anything, please feel free to hit me up. And I'm also on Twitter, which is kind of my main way to get information out to the community for things like blog posts. And that's the URL for my blog there. Uh, Blog frequently on PowerShell on Linux, SQL Server on Linux, and things like that. And I'm also a Pluralsight author. And so a lot of today's content comes from a series of courses that I've done on Pluralsight. And if you want access to those for free, shoot me an email. I'll give you a 30-day code, not because I'm trying to sell you something, but because you'll have access to all of that content in the hours and hours and hours of me blabbing about Linux on Pluralsight. But you'll get much deeper dive stuff there than we could cover in the hour that we have together today, because it's really hard to teach someone an entire operating system in like an hour. And that's pretty much what we have, and have lots of bullet points that we're going to fly through. So these are the things that I think are important for people getting started with Linux, right? The big bucket items. And each one of these we could spend hours talking about, but these are kind of the big bucket items that I want to go through to help you guys get started right, on your journey. And first, we'll start off with the architecture, what it looks like conceptually, Linux it is. And then we'll look at how to interact with our system. We need to be able to do stuff on the computer and have it do things for us. We'll look at one of the fundamental ways to move data with IO redirection and pipelines, which certainly is going to be interesting to you guys since you're used to an object-based pipeline. We're going to look at what's called a byte stream or a text-based pipeline today. We'll look at file system basics and the fact that in Linux, everything is a file. We'll look at working with PowerShell on Linux and PowerShell Core, and also how to work with packages. We're going to be able to install stuff on our servers and our systems so that we can do things, right? Make the computer do the work that we want it to do. We'll look at managing services with System D. So PowerShell people are used to using things like get service and set service and restart service. Will conceptually have a similar functionality in the operating system initialization manager or initialization daemon called System D. We'll look at system resource management, so basic CPU, disk memory, performance metrics, and where to look at inside of our operating system. And then finally, we'll wrap it up with where to get help. And so in the Linux architecture, really it's it's just like every other operating system. It has one function, and that's to control access to the physical resources in our computer, things like CPU, memory, and disk. And how it does that is with a thing called a kernel, right? It's the kernel's responsibility for resource management and access, and to provide those fundamental operating system abstractions like a process, which executes it or represents an executing thing in our system, or pages like memory pages are allocated in memory, and then also file systems so they can interact with the disk. Now, what we do as users is we need to be the ability to execute programs, and our program's job as they're executing inside of our shell is to interface with the kernel, right? So the work that our program is doing is then going to ask the kernel for things that it needs to have access to, right? Processes, pages, file systems, or things like that. So if an executed program needs to start a new thread or a new process, it's going to ask the operating system to do that. And it's going to do that via what's called the system call interface. And the system call interface is kind of the arbitrator that allows access into the kernel for those privileged resources. And of course, at the top of our architecture is us, right? We interact with the shell, we do what we do, and we cause problems. So from the top down, users execute programs. The program interacts with the kernel via the system call interface. The kernel does the work on the actual hardware itself. I'm going to throw two terms at you guys: kernel space and user space. Our program's generally going to be running in user space, right? The things that we're doing to calculate an averages, whatever our program is built to do. But whenever our program has to transition to access physical resources, it's going to transition into kernel space. It's going to do the thing that it needs to do in the physical hardware, return that back to user space for consumption. I did just realize, James, I can't see the questions on the thing. So if you want to if there's a question in the chat, let me know, please. So let's talk about interacting with our Linux system, right? We need to be able to get on that system and do some things. And there's two fundamental ways that we're going to have access to a Linux system. It's going to be via a text console or graphically, right? And so if I predominantly going to interact with, if you're a server person like I am, you're going to interact with the Linux systems via text, right? You're going to the command line functionality that you're used to maybe in the Windows world in DOS and PowerShell. If I'm sitting at the computer, of course, I'm going to have console access to the system, and I'm going to get a text-based prompt. But primarily, again, if you're a server person, you're going to interact with your system remotely, and you're going to do that via what's called secure shell or SSH. And there's kind of a whole slew of ways that you can get access from remote systems into Linux systems, which kind of go through the big bucket ones today. If you're sitting on a Mac, which we're going to do today, you're going to log into Linux systems via terminal, right? A terminal app, which there's a similar one on Linux as well. In the Windows world, you might be used to using something called PuTTY, which is going to give you remote, again, SSH remote access into Linux systems. But that was kind of the de facto way up until about a year or two ago. And then things got busted wide open with the new Microsoft. And we have things like Windows services for Linux. And that's kind of become my uh, most used way that I'm going to use SSH now is I have Bash for Windows on my Windows box that I have here. And then I just use straight SSH out of that Debian installation or Ubuntu installation that comes with Windows services for Linux. There's also a Win32 port managed by the PowerShell team of OpenSSH. So literally they forked the code and are now supporting and maintaining a fork of GitHub or of OpenSSH in GitHub, which is available to you for consumption today. And it will be part of, I think, Windows Server 2019, which I think is pretty fantastic if you think about the shift in the operating system platform and concepts inside of Microsoft, be able to actually deploy or package and ship OpenSSH inside of a Windows operating system. We also have the ability to log or interact with our systems graphically via what's called a desktop manager. In the Windows world, you might be used to using only one desktop manager, Windows. In Linux, you can run no desktop manager at all, which is predominantly what I do on server-based systems. But if you do need to run a desktop manager, things like GNOME and KDE, there's several desktop managers available to you to manage your system. Now, if you're going to log into those systems remotely, graphically, VNC is the way to do that. And so now let's move on into access or privileged access, right? Now that we know how to get onto the system, maybe we need to do something with administrative rights. And let's talk about the differences between the two. So in Linux, security is based on user IDs, like literally numeric user ID. That's an integer value. And there's a special one called root, whose UID is 0. And it's the root is effectively like conceptually similar to administrator in Windows boxes. There's literally no security boundaries around what this user can do. It's meant to administer the system. Now, conventionally, when you're logged into a Linux box, you're going to see a pound sign at the command prompt, right? And that's going to indicate that you are logged into the system as root with privileged access. And so on the right there, you see root at rel1. Tilde is indicative of me being in my own home directory, and then followed up by that pound sign there on the end. You really want to try to avoid using root because, again, there's no security barriers around what this user can do. If you want to delete every file in the file system while its server's up and running, you can do that. It's cool. You'll be able to work until you reboot the system, and it probably won't ever start again. So what you want to do is you want to log into the system with regular named users. Again, conventionally, you're going to see a $sign at the command prompt to indicate that. So on the right there, you see demo at rel1, and then a $sign. Those two characters come from Bash, and Bash is what's doing that manipulation. You could have a smiley face there or any other emoji that you'd want, but Bash out of the box is going to have a pound sign for root and a $sign for non-privileged users. So that leaves us to the question: how do we get between a regular user account and into a privileged user account or into the root to do some work? And one way to do that is with the su command, which is short for switch user. And you can use the su command to switch into the root user by just typing su. You hit enter, and it's going to ask you for the root user's password. Or more specifically, it's going to ask you for the destination user's password. So if you run su with no parameter, it's going to assume that you want to transition to root. If you run su with another username, maybe AEN or demo or some other username that's on that system, it's always going to ask you for that destination user's password, which really isn't good because now you have to share those passwords with people if you need to switch security context. And specifically switching into root, you want to make sure that that password is protected as much as possible. So we can combine another command with su to switch into root, which we'll do in some of our demos today. There's a command called sudo, which allows users to execute an individual command with escalated privileges. So I can type sudo and any other command after that, and that target command will be executed with privileged access. The good thing about sudo is it's going to ask you for your password rather than whatever you're trying to do with that system. So it's going to be your password, and we can combine sudo with su to take our regular user account and switch over into privileged access mode and still use our password. And I'm going to show you guys how to do that in a demonstration today. Now, this isn't out of the box stuff, right? Not everyone can make this transition. Sudo is protected with a configuration file where you can control who can do these privileged accesses and things like that. A little bit out of scope for today's conversation, but if you are installing, for example, CentOS or RHEL out of the box, there's a checkbox that says, make this user an administrative user, and this is what it's doing under the hood. It puts you into the right group, which allows you to use sudo without any restriction, and then you can do administrative tasks. So this is a quote from a book called The Unix Programming Environment, written by Brian Kernighan and Rob Pike. If you don't know who those guys are, when you're bored tonight, you want to go to sleep, go to the Wikipedia and look up who those guys are because they pretty much invented the C programming language, Go, and things like that. And in this book, there's a quote that's kind of stuck with me for a while. It's many Unix programs do quite trivial things in isolation, but combined with other programs become more general and useful tools, right? This is really key to the Unix philosophy of having one tool do one job and do it really, really well, and then combine those things together to do those more complicated tasks. And so let's look at how we can combine those things together to perform those complicated tasks. And the kind of the fundamental way that occurs is with a thing called IO redirection. So if I'm a process that's executing on Linux, I'm up and running and I'm doing work, inside my process address space are a collection of file descriptors with a specific purpose. And let's walk through those. File descriptor 0 or standard in, right? So any input into my process is going to be read off of this file descriptor. So if I'm sitting at the keyboard and I want to send commands into a process, I'm going to, by default, look at file descriptor 0 and read from the keyboard. Now, if I generate any output in my program, I'm going to write that to file descriptor 1 or standard out. And the default destination for standard out is to the terminal or to the console, straight to the screen. There's also a third file descriptor 2, or standard error, which by default writes to the terminal as well. And so now here's where we start to get to do some cool stuff. We can take these file descriptors and change their destinations or where they're reading from. And so, for example, file descriptor 2, let's say we have a program that's doing something wonky and we want to catch those errors rather than writing them to screen. We want to write them into a file, and we can do that very easily. We'll look at the syntax and how to do that in a second. But I can also take things like file descriptor 1 and write the output of that to file as well. Or even more interestingly, I can take the standard input and change that to file input and change the inputs and outputs of how these things exchange data or the processes themselves. We control that with a particular syntax, which we're going to look at in a few minutes. Now, let's look at how we can take that concept and extend it, right? Not just in that we need to exchange information from a process in its inputs and outputs to files and to screens and to and from keyboards, but maybe we can use that to exchange information between processes, right? And the way that works is, let's say we have a command executing like ls, right? And by default, it's going to read from the keyboard and it's going to write to the screen by default. And how many times have you done a directory listing and it runs off the screen and you scroll up, and that's kind of a pain. And so there's another Linux command called more, which what more does is it puts one screen's worth of text on a screen and it stops. You hit the space bar, then you get another screen's worth of text, right? So we can combine those two commands together, right? We can get ls, wrangle it and get it under control such that we only get one screen's worth of information at a point in time. Now, how do we get that output from ls into more? Well, we do that with a pipe. And what that pipe does is, under the hood through inter-process communication, is it connects file descriptor 1 or standard out and sends that directly into file descriptor 2 or file descriptor 0, standard in of that destination process. And that information flows out of ls on file descriptor 1 and directly into more on file descriptor 0. And then you get one page worth of output for that directory listing. And then Moore's file descriptor 1 or standard out just sends it off to the terminal in that controlled fashion. This is called a process group. And this is kind of the core to how we build those more complicated commands to have our system do those cool things. Now, If I was presenting this in person, I would jump in front of the screen and say, "Don't look at this. This is really a reference slide for you guys, but it's kind of hard to jump in front of the screen because I'm sitting in my office." But we're talking about IO redirection and pipelines and the various ways we can do that. So, how to write things out the file, how to read things in from file, how to capture a particular file descriptor and write it out. So, you can see kind of in the middle of the page there, I have a two and then a greater than sign. That's how we grab that file descriptor two for standard error and send it off into a particular location. So, let's move on and talk about the Linux file system, kind of working our way through those big bucket items now. The Linux file system, everything is a file, like literally everything. When we're looking at our disks or things like that, of course, we're used to seeing things like directories and files and whatnot inside of those. But in Linux, all of the entire operating environment is represented within a single file system hierarchy. So processes are represented as files inside of the Slack proc virtual file system. Devices show up inside our system as files. And that common interface gives us a lot of simplicity in how we can interact with those things. So we do things like read and write to all of those various things and make modifications to those files in that particular way. So the most common way that we're going to represent a file system is within a tree, but it's a little bit different from Windows in that there's no concept of like lettering or things like that. Everything is based off of the root of the tree or that single forward slash. So you see the forward slash there at the top of that picture, and then the various subdirectories underneath it. And so I kind of highlighting the more commonly used subdirectories that you're going to see on a Linux system walking up to it the first time. So bin right there, you're going to find in bin is, or sometimes symbolically linked to USR bin, are programs that you're going to execute frequently on the system. Var is short for variable directory, where you're going to find things like your logging directories, your mail spools, your print spools, and commonly you'll see database files land in there as well for MySQL and also SQL Server. There's a slash home directory. Instead of there, you'll find a directory for each user on the system. So here you can see demo one, demo two, and things like that. There's a USR directory for locally installed programs, and then this slash MNT directory. Conventionally, you'll mount remote file systems or remote media in slash MNT, right? So if I want to mount something or a share from a remote system, I conventionally stick it here. Or if I stick in some removable media, I'm going to mount it there as well. That's again conventionally. It's not uncommon to take a remote file system and mount it in other parts of the file system. So, for example, if you have a high-speed disk subsystem, I'm going to stick that under slash var opt MSSQL for SQL Server, right? And then finally, Etsy or ETC is where we keep our system configuration files. And we're going to go looking at that in a little bit. So if you want to fall asleep tonight, go ahead and Google the file system hierarchy standard. This is the standard Unix file system layout. I think it's like 60 or 70 pages. It describes rigorously what each and every one of these directories is supposed to do conventionally. But the good thing about that is if you walk up to any Linux system, they're going to look very, very, very similar because of the standard. So let's go ahead and jump forward and talk about working with PowerShell and Linux or PowerShell Core. It's available now, which means it's in GA and we can get that. I think it's in 6.0.1 is GA and 6.0.2 is in preview. And those guys are banging out code at a wild pace. About monthly was the cadence. I think it's slowed down slightly recently. That's just my observation. But they're banging out code very, very quickly and adding tons and tons of features. And a lot of the commandlets that you're used to are available to you today. But there's kind of a shift from the old full .NET into .NET Core, which is really the biggest barrier to getting new commandlets or getting full commandlet coverage over into PowerShell Core. If you want to, and you don't like using Bash, you can actually set PowerShell as your default Linux shell when you log into a Linux system. Literally, you log into the system via SSH and boom, you land right in PowerShell. And there's a bit.ly link there with instructions on how to pull that off. If you were at PowerShell Summit this year, you saw me do 2 deep dive sessions on PowerShell remoting and how that works in Linux systems. So we can leverage the same PowerShell remoting concepts that you're used to in a Windows world in a Linux world, but it's a little bit different in how it works. WSMN and WinRM exist, but I think that kind of story is shifting a little bit and haven't seen a lot of development there in about the last year. But basically, you have to disable things like Kerberos and regress to like basic authentication, things that you'd probably never want to do in a production system. They have given us a very reasonable replacement for PowerShell remoting as the underlying substrate for remoting, and that's OpenSSH. And I don't know if it's online yet, but both of my sessions will be on YouTube from PowerShell Summit. If you want to get deep dive into how that works and how that sets up, how that gets set up in a mixed or cross-platform environment. So as PowerShell people, if we are using PowerShell on Linux, I think the thing that you want to look out for is command aliases. So you might be used to seeing on PowerShell on Windows aliases like MV, which calls move item. But on Linux, they kind of they didn't want to take over those commands from Linux people, right? There's a whole collection of aliases, I think like MV and CP and LS, that the product team did not want to take those away from Linux people when you launched PowerShell. So if I launch PowerShell core on Linux and type MV, I'm going to get the native operating system MV command to move a file. Now, what that means is if you're expecting a particular output from commands or commandlets, that you need to handle that in specific cases. But if you're writing scripts, pretty much the convention is don't use aliases, right? But I just wanted to call this out to you guys. If you are banging away at the command line, know that your output from MV on PowerShell core is certainly going to be different than it would be on Windows. So let's get into a demo, lots and lots of talking. We're going to go ahead and connect to our system via SSH. We're going to look at basic process management, and it's not a PowerShell demo without using get process. And then we'll look at how to build some command pipelines together. And so here I have the terminal app on my Mac, and I'm going to log into my system with the username at hostname. So I just type SSH space, and then the username that I want to log in as, and then the @ sign, and then the server name that I want to log into. And here you see it's going to ask me for my password. If you're interested in key-based authentication, that's covered pretty extensively in my PowerShell Summit presentation. So now that we're in here, let's go ahead and get started with some demo. So if I just need to simply execute a command on Linux, I just type the command and hit enter. So PS, right, for process select, it's going to give me my processes that are running. So you can see I'm running the bash shell, and the other process that is executing at this point in time for me, for my user, is PS. If I want to go ahead and pull that command back up, I hit the up arrow and I can make a modification and say -AUX. I want with -AUX is going to give me all of the processes on my system. So you can see I get this big list of stuff that's all of the executing processes on this Linux system. And so let's go ahead and build a more complicated command, but a command to go ahead and pull off maybe the top 10 processes by CPU. We're going to do that together now. And if I want to take that output that we have from PS, I want to pipe that into a command called sort. And sort's just another Unix command that just does one thing, and it does it well. It sorts stuff, right? And so I go ahead and press enter, but it's going to sort it in a way that it expects things to be sorted. So in this case, it's going to sort our data by the first column of data, and it's going to do an ASCII sort. So you can see here I have the username that is the owner of that process. But at the very bottom here, I see the column headers for the PS command, right? So here's the username, process ID, percent CPU, percent memory, etc. And that's because it's doing an ASCII sort on that data, and capital U comes after lowercase r. Now, I need to tell sort to sort things in a way that I want it to so that I can get the top 10 processes. So I'm going to do NRK minus NRK3, which is going to sort numerically in a reverse order on key column 3, which is 1, 2, 3, that CPU column right there. You're like, NRK3, how did you know that? It's because I've been doing this for 20 years and I know how to read man pages, but I'm going to tell you about that in a little bit. So let's go ahead and combine NRK3 with another command called head, and that's going to pull off the top 10 lines of output. So now we have a little bit better of output building this command together. So we have PS minus AUX getting all of the processes. We have sort minus NRK3, which is going to get me that third key column, which is going to be our CPU utilization. And head is going to restrict the output to just the first 10 lines of output. But see, it's still not right in that we have a process here and then our column header information in the middle of that, right? So again, we're sorting by CPU utilization. So I have to go ahead and deal with that. So I'm going to go ahead and make an edit to my command, minus, no headers. And you're thinking to yourself, why is he dragging me through this? Right? So now I just removed the headers, and now I have 10 rows of output sorted by CPU utilization. I don't have a huge workload going on. So it's kind of a SSH is kind of the big heavy hitter right now. And the reason why I'm showing you this is because now we're going to do that same exact thing in PowerShell. So I'm going to launch PowerShell with pwsh. And I'm going to do the same thing. And I'm going to do it in a way that you guys are probably familiar. So get process, right? I have tab complete here, pipe sort object, do sending or descending CPU. And then I'm going to do select object, first 10. And I get the same thing, right? I get the top 10 processes on the system, but I don't have to sit there and wrestle with all of those things that I had to wrestle with when I ran that command in Linux, right? Or using the Linux native tools. I'm not saying one's good or one's bad, but I'm saying is you guys have the ability to do this today, right? And one of the things I do like to say is that's a lot more approachable than this, right? For this, I've 20 years of experience reading man pages, muscle memory, all that fun stuff. But get process, sort object, by CPU, give me the first 10. That's pretty cool that you guys have something that powerful available to you in Linux. There's a story when I got involved with PowerShell, because I've only been involved in PowerShell probably for about a year and a half now. And Jason Helmick and I were working on a project where we were shooting a training video, and I'd never really used PowerShell before that. I was the copy and paste PowerShell guy. And I sent him an email, and I sent him these two lines. I sent him this line, and I sent him this line. And I was like, which one of these two things do you think I like better? And he's like, he tells the story. He's like, he's rubbing his head. He's like, damn it, no, Santino's going to be the crotchety Unix guy and give me a bunch of heat. And I'm like, no. I'm like, honestly, I really enjoy this syntax, right? Even over what I've been using for decades with the traditional Unix commands, because of the readability and the object-based pipeline that allows me to deal with this data in its native types, right? Which is something that we've always had to wrestle with as Linux people, is dealing with things as byte streams, or just strings that are popping out, and dealing with the conversions and -- no headers and NRK3, all those different things. So with that, let's switch back to, we covered all of those. So yeah, so just a quick recap. We logged into our system via SSH. We looked at some basic process management with PS. We then looked at what you guys are probably used to with get process, and we walked through building some command pipelines. So remember, when you type, PS and pipe that in the sort, that's all. Remember that file descriptor 0, file descriptor 1, and how it flows through all of that. Conceptually, I'm pretty sure that's how it's implemented under the hood inside of PowerShell, but don't hold me to that. So now let's talk about how to get our computers to do stuff for us. We want to install software. And the way that we do that in most systems, and I'm going to focus primarily on CentOS and RHEL because that's what I use in corporate environments and have been using for a long, long time. And I just think it's better than the other stuff, which we'll talk about in a second. So RPM is short for RPM Package Manager. It used to be short for Red Hat Package Manager, but now it's just RPM Package Manager. And it's a package management system, which gives us the ability to have packages or collections of programs and scripts to deploy software. And the interesting part about a package is that the metadata that goes along with it. Inside that metadata, it's going to describe the package, the files that are in there, the scripts that are in there, version information, and also any dependencies for that package. And so that becomes a critical piece in how we're going to manage the deployment of software to our systems, which we'll talk about in a second. So a package management system is a suite of tools that allows us to do things like install or upgrade or remove packages on our system, right? Again, those are programs that we need to deploy and the scripts to get those things set up. Now, the thing about RPM out of the box is it doesn't provide dependency management, right? So if I type yum install package A and package A requires package B as defined in its metadata, RPM is going to say, you need package A installation, or you need package B, package A installation failed. And it's not going to do anything for you, which is great, right? We'll talk about how we can fix that or make that a little more easy for us in a second. Conceptually, RPM runs up against a thing called apt or dpackage in the Ubuntu and Debian worlds. So those concepts apply, just those are the programs that you'll be using on that side of the fence. So let's talk about how we resolve those dependencies. And the way that works is with a thing called a yum. Again, on CentOS and RHEL-based systems, you'll interact with yum. Yum is also classified as a package manager, but the cool thing about yum is it does dependency management. So if I type yum install package A, it'll look at the package metadata inside of package A, be like, oh, you need package B? And what it's going to do is it's going to go and look at the collection of software repositories that are installed on my system and reach out to one of those repositories and say, hey, give me package B. It's going to install package B, and then it's going to go install package A, and I'm going to go about actually doing the work that I want to do, and I have to chase down those dependencies manually. So I used a term a second ago called repositories. And repositories are where software is stored to be distributed to systems. And the way that you can distribute that is pretty much any reasonable protocol you can think of: HTTP, NFS, FTP. Um, there's one other one, direct files, and things like that, where I can go and define a repository on my Linux system. And in there, it'll say, this is where that repository is found, maybe at this particular URL. We're going to look at that in a second in the demonstration. So, who, I guess you're going to say, who maintains those repositories? And the biggest ones that we want to interoperate with are the ones from our software publishers, things like Red Hat and CentOS, and now even Microsoft, which we'll talk about in a second. But those base mainline repositories like Red Hat and CentOS are where we're going to get the majority of our packages from. So if I type yum install HTTPD for Apache, it's going to go out to Red Hat. It's going to download the latest one and install that for me. And any subsequent dependencies would also be retrieved from the software repository installed on my system. Now, there are third-party repositories, things like EPEL or Extra Packages for Enterprise Linux or RPM Forge, and also Microsoft is also publishing RPM repositories as well, or Yum repositories. And that's how you're going to get PowerShell. That's how you're going to get SQL Server, is using Yum repositories. EPEL is Extra Packages for Enterprise Linux. It used to be a community project, but now it's kind of underneath the umbrella of CentOS, in that that's packages that aren't part of the base repositories from the mainline publishers like Red Hat and CentOS, but do publish a broader collection of programs. So things like HTOP, which is a very valuable performance tool, isn't available in Red Hat's repositories. It comes out of EPEL. A common use case for using for EPEL is a couple years ago, I had a customer that needed to install MySQL 5.5. And at the time, the base repository for Red Hat only deployed 5.1. But that customer needed a particular feature of 5.5, and we didn't want to build it from source. And so we installed EPEL and we deployed MySQL from that third-party repository and still got all the benefits of having updates and things like that from the repository, but we did branch away for that particular package. So that's a common use case as well. You can also build your own repositories. This is common if you're deploying your own software inside of your data center, or if you want to mirror one of the production repositories and then point your internal systems at that mirror, you can build your own repository to do that. One of the other cool things about Yum is it provides system-wide updates. If I type Yum update, it'll update every package on my system. If I type Yum update and a particular package name, it'll update just that package. So a very simple update interface with Yum. Again, conceptually, apt has all of these things as well. And so let's go ahead and look at some package management with Yum. And we're going to install SQL Server on Linux on our demo system today. So normally I don't copy and paste during demos. This command is a bear. And so we're going to copy and paste it together. And so let's walk through this big command that we have from left to right. So this is the first time we're going to use privileged access on the system. We were just doing basic stuff a second ago, or non-privileged stuff a second ago. And I'm going to combine this sudo command to go ahead and use curl with privileged access to go and read a particular URL. So curl is a command line web browser essentially. And I'm telling curl to do is to reach out to this URL, https packages.microsoft.com, and download this file, this mssql-server 2017.repo file, and then stick it in this location. So etc, right? That's where we stick our system configuration files. Etc yum.repos.d. We're going to stick that file right there. And so let's go ahead and do that. And we'll need privileged access because that directory has security around it such that not regular users can make a modification like adding a software repository, which is what this command will do. So we stick that file in that location, and we've now configured a software repository for our system to use. So if I go and I look at that file, I'm going to use the command more, then the full path to the file name, and I get the contents of that file, simple text file. But the fact that it's in this location makes it part of our Yum configuration and part of the repositories that we'll interact with when we need to go download software and things like that. So here you can see we have the package, the configuration name, the repository name, the URL, which this base URL for where it's going to retrieve packages from, the fact that it's enabled, we can simply change that to a 0 if we wanted to, and a GPG check. If you think about what we're doing here in the key, If you think about what we're doing here, we're pointing our system at an arbitrary system on the internet, downloading stuff from it and installing it on our system. Wow, that sounds like a great idea if you're a security person, right? But what this does here is guarantees the authenticity of the remote system. We download that key, we store it locally the first time we interact with it, and subsequent interactions with that system will be validated based on that key. And I know that that system is who it says it is. Right? A very valuable piece of security provided there. So let's go ahead and install our first package together. And again, I'm going to need privileged access to do that, to install stuff. So I'm going to type sudo yum install mssql-server. I'm going to throw a -y on there. And what that's going to do is answer any yes, no prompts automatically with a yes. And so sudo for privileged access, yum, our package manager with the verb install, right? That's definitely something that we want to do. And then the package name, mssql-server. So what it's going to do now is it's going to go down and you can see it has the packages.microsoft.com msql-server 2017 um, repository configured, and it goes in there and it finds what we're looking for. It finds the package msql-server for our particular system in that repository, and now it's downloading it from the internet and putting it on my system. And I have a pretty slow internet connection here. This is, I think, like a 167 megs, and brutally going to take a minute and 20. So while it's doing that, we're going to jump over here and continue presenting. So what we've done so far is we've downloaded that repo file, we stuck it in the right location, and then we interacted with it just simply by typing yum install msql-server. So pretty cool functionality there. So while that's cooking in the background, let's talk about managing services with systemd. Now, systemd is what's called an initialization daemon. Its primary function is to control the state of the system, right? Basically, get that system up to a running functional operating system to provide the services that it needs for users to consume. So it actually manages the boot process, the starting and stopping of services, and the transitions between those states on our system. There's concepts like single user mode and multi-user mode, or multi-user targets in Linux systems based on which services are started and stopped at those different states. Systemd is in charge of that. It's also in charge of things like logging and other things like timing and events, and also mounting file systems. But we're going to kind of zoom in on services today because as Windows administrators, it's a thing that we're kind of familiar with conceptually and how we control what's running on our boxes. So the way that we do that on Linux is with a command called systemctl or system control. And so system control, again, very similar to using things like get service and set service. And we'll look at some examples here in a second. With system control, we can verify if our services are up and running, if they're stopped, started, if they're enabled to be started, with the system is running on boot, or excuse me, when it's coming online, and also manages before and after dependencies. In that, I can say that service A has a dependency on service B, and it won't start until both of those services are started. Now, under the hood, when we're talking about systemd, is this concept of units and unit files. We're going to look at those in the demos today. But abstractly, a unit is anything that's under systemd's control, right? And so we're going to zoom in on service units today because again, that's what we're going to be focusing on. But there's different types of units for all the various things that systemd controls. One of the other things that systemd provides is also logging. And any systemd unit that's managed by systemd will send its information into the journal, which is a place where we can go and query to get log data about the services or any of the other events that are being managed on our system. And so let's go ahead and slide back into a demo and use system control to do things like enable and disable process or services, check the status of, and also stop and start systemd services. So while we were talking, SQL Server finished up, and I'm going to go ahead and run the final setup script for SQL Server, which is just going to ask me to type in which edition. Of course, I have to agree to the license agreement and give it a password. But we're not going to focus on that part. We're going to focus on the systemd elements that support SQL Server under the hood. So with that installed and ready to go, let's do systemctl and check the status of MSSQL-server. Actually, before we do that, let me do this. I want to do systemctl because I want you guys to understand that how I figured that out. And so I'm going to what the name of the SQL Server unit or service was. And so if I do systemctl list unit files, let's go ahead and throw a sudo on the front of that. What this is going to do is spit out all of the systemd units that are on my system, right? So anything that's managed by systemd. So here we can see the unit name. So you see arp-ethers, and then the unit type dot service. So scopes and paths. These are all the different types of systemd units that are managed by the system. So how do I find the one for SQL Server? Well, I'm going to take a wild guess, and I'm going to combine the output of that command. I'm going to use grep, which is a pattern matching tool. I'm going to grep for the text SQL. Linux is case sensitive, so maybe I want to put the -i parameter in there to ignore case, right? So we take the output of all those commands of that first command, grep that into, or pipe that over into grep, and find that I do have a service named mssql.server.service, and that it's enabled. So now I know the name of that particular service that I want to go interact with. So sudo systemctl status mssql-server. So here we can see a whole bunch of information that represents the current state of this particular systemd unit. So there's the unit name, which is mssql-server, the type, service, and then a text description of what it is, just the database engine for SQL Server. We can see on this loaded line here that the systemd service or unit is loaded. What that means is systemd knows about this particular service unit. It doesn't mean that it's up and running. It just means that it's loaded and registered as part of the things that systemd manages. Now, that systemd unit is implemented inside of this file here. We're going to go ahead and throw that in a clipboard and look at that in a second. We see that it's enabled. What that means is that if this system rebooted right now, SQL Server would start automatically when the system came back up. You can see that it's active. This means it's actually up and running, and it's been running for this long, about 1 minute and 49 seconds. There's a link to some very awesome documents there, and then the main process ID, and then the binary that's being run by this particular unit. Now, what we have here is the last 10 lines of output from journal D for this particular unit. And if you go from left to right, you can see the name, the host name, the process ID, and then something that's probably familiar to you if you're a SQL Server administrator. This is the actual contents of the SQL Server error log. That gets written to systemd, and we can use that to read or interact with our SQL Server and find out what's going on in its boot process or in its error log process. So I told you we would look at that unit file. So in usr-lib systemd system mssql-server.service is the file that defines what this service is. So let's go and check that out. And inside of there, we can see this syntax. We see the service, or you can see that it's of type service, the binary of the program that's launched when we start this service, who it's launched as, and then the working directory. So in here are the things that define what this service actually consists of. So with that, let's go ahead and do something a little more interesting. Do systemctl stop mssql-server. And that's going to stop that systemd unit. Notice I didn't have to type my password that time when I used sudo. By default, sudo will cache your password for 10 minutes between executions. So now I'll go ahead and use the up arrow to pull back our status again. And now we can see a little bit different output. We see that we're still loaded, certainly because systemd knows about it. And we're active, or our active status is now switched to inactive dead and how long it's been dead for. We stopped this SQL Server gracefully, so it's going to shut down and it's going to stay shut down. But by default, actually, if SQL Server crashed, systemd would automatically restart this service for us. And you can see that in the syntax right here. Restart equals on failure. So that was inside the contents of our systemd unit's definition. So if SQL Server crashed for some unforeseen reason and had a dirty exit code, it would simply restart that for us, which I think is pretty cool. But that wasn't the case for this particular shutdown. It was a graceful exit, so SQL Server will stay shut down. And we can see that here, that the status exit, the code is exited, status is 0, which is a clean shutdown success. And in our error log, we see the normal output of SQL Server stopping. So certainly we want to go ahead and start that back up and get SQL Server running again. If we check our status, we can go ahead and see that it's back up and running. We don't have any output yet. We can run it again, and there we go. We can see we have the last 10 lines of the journal for that particular unit. So one of the common things you might want to do when we're installing software is find out what's installed. And a common way to do that is with a tool called RPM Query. And I'll go ahead and maybe dump out all of the output to the screen. That's going to literally list everything that's installed on our system. Probably not a good way to figure out what's installed. I can pipe that over into grep, again, that pattern matching tool. And I ignore case. Again, let's go ahead and look for SQL again. And we can see the tools or the things that are the packages that are installed on our system that match that string. It's a good, easy way to find out, hey, is this installed on our system? We can also use yum to help us with that as well. Say yum info, msSQL-server. And we can see that info, yum, yeah, repo install. There we go. Totally blanked out on that one in the middle of the demo. It's all good though. So let's go ahead and switch back. We learned a lot about interacting with systemd, starting and stopping, and checking the status of our systemd units. So let's talk about resource management inside of our system. So big bucket items, we have CPU, disk, memory, and network, right? Those are the big things that we're concerned about from a performance standpoint. We're talking about the operating system as a whole. And when I'm looking at things like CPU on a Linux system, we're going to have a thing that's maybe not so in the forefront as it is on a Windows side of the house. When on the Windows side of the house, we use Task Manager and we see percent CPU utilization. Well, one of the primary metrics that I'm concerned about on the Linux side of the house, or I guess it's more in the forefront in the tools that are provided, is a thing called load average or run queues. And what that is the number of processes that are in line to get access to the CPU. If we start to see those run queues increase or the load averages increase, that means things are waiting to get access to the CPU. And so it's not necessarily just a percentage value, but it's an integer value that represents the number of threads that are waiting for execution. That's how I judge CPU utilization on Linux systems. That concept certainly exists in the Windows world. The point I'm trying to make is that the tools that we use by default, I think on the Windows side of the house, focus predominantly on percent CPU. At the Linux side of the house, they'll focus on load average. Disks, of course, we care about space, like how much space is available, and latency, and also a concept of I/O weights, which we'll talk about in a little bit. Memory, we certainly care about memory pressure and any swapping that's going on. So we want to make sure that we have sufficient amount of memory free for the processes that are running on our system. And of course, network, we care about throughput, latency, and reliability. And if you're a SQL Server person, you have all that standard DMV data available to you. So if you're getting in there for performance, that's available for you as well if you're using SQL Server on Linux. So of those metrics that we care about, things that the CPU, disk, and memory, these are the tools that you're going to go to first to answer those questions. So top is kind of the de facto or the task manager tool that you're going to use to go and say, what's running on my system right now? It's going to refresh every 2 seconds and give you the top processes that are executed in your system. You could sort it by various columns, like per CPU utilization, memory, and things like that. HTOP, I think, is significantly better than top in its visualization, its sorting and selectability, and the ability to interact with processes. That's available in EPEL if you want to install that. So you go install the EPEL repository, then install HTOP, and you'll have that available. VMstats, how you're going to find out if you're swapping or not. Are your processes actively paging to disk? And that's going to be your go-to command for that. Free -m is going to give you the available amount of memory on your system in megabytes. It's actually going to report total available buffers and free, which are different concepts for memory management in Linux, but making sure that you have a sufficient amount of memory in your system such that you don't have to use VMstat to find out if you are swapping or not. If you want to find out a particular size of a particular directory, du -chs, and then that path to that directory is going to give you a the size of that particular directory in human readable format. df minus h will give you per mount. Disk utilization. We talked about mounts in the beginning, where we can mount different disks and things like that in different parts of our file system. df will give you the output for each of those mounts and the total and available and used disk utilization. If you're into performance, you need to understand what's going on inside of your system. Check out a tool called dstat. That's kind of the monitoring Swiss Army knife, where it does all the things that we just talked about and much, much more. It's also extensible, so you can add in your own tools to interact and find out what's going on in your underlying operating system. Dstat's kind of that point in time tool that I want to find out right now what's going on. If you need to find out historically what's going on in your system, you're going to want to install a tool called SAR, which gives you the ability to go and answer the question, what happened when, right? It's going to take periodic samples, store that data in a binary file, and then you can query that file, pull out that information between time X and time Y, and it'll tell you what happened from a performance standpoint in those intervals. Very valuable tool there. You can also configure it to email you reports periodically. So from a performance standpoint in Linux, let's go ahead and walk through the subsystem, what you're used to seeing in Windows, the Linux tool that pulls that out, and then the key performance metrics in Linux for that particular subsystem. So if we're looking at CPU and you went into perfmon, you would look at percent processor time. In Linux, you're going to use top or htop, and you're going to focus on, of course, CPU usage and percentages, but also load average. Memory, right? In Windows, you would look at percent bytes committed in use. In Linux, you're going to use free minus m. You have the total amount available, how much is being consumed, how much is free, and how much is dedicated to the file system cache. Disk space, of course, we look at percent free space, df minus h, so we have total used, available, and per mount. Disk IOs, right? If you're into disk performance, we care a lot about IOs. Disk transfers per second in Windows. IOstat minus dx is going to give you this output on the right, which is transactions per second, reads per second, and writes per second. Disk latency, of course, we care how long it takes for that stuff to be written out the disk. So we look on Windows, we look at averaged disk seconds per transfer. IOstat minus dx is going to give you two values, awaits, right, and service time. Await's going to be pretty much the way that you're going to go from a file system standpoint. Now, what await measures is the amount of the file system call into the driver and then out the disk. Service time measures from the driver out the disk. But due to the way that the kernel accounts for IO transactions, service time is deprecated in systems and it's going to be removed from IOstat. But you probably will see it in some of your output and on blogs and things like that. But service time is going away because it can't handle parallel disk queues like NVMe accurately. IO sizes, average bytes disk per transfer, IOstat minus DX, and that's going to be the output average request size, which again is valuable for performance. When you're looking at performance data on the network side of the house, in Windows, you would look at bytes per second, which I think is comical. It's a perfmon counter about network utilization. It's measured in bytes. And I don't know a network engineer on the planet that measures throughput in bytes. But if you went and Googled, network monitoring tools for Linux, you're going to literally see blog posts like top 20 network monitoring tools. There's tons and tons and tons of them out there. And these are the three that I use pretty frequently. IFSTAT, BWM-NG or Bandwidth Monitor NG, and NLoad. One I was just introduced to kind of recently is NetHogs. Does a fantastic job of telling you who is consuming the bandwidth. And of course, the counters that we care about coming out of these tools are things like packets per second and bits per second, the actual consumption rate. Now, I did tell you about dstat a second ago, being the monitoring Swiss Army knife. Check that out because it does all of this stuff in one tool. So let's talk about getting help. We have the man pages on Linux. So if you type man and then the command name, you're going to get a whole slew of information about that command. In fact, if you Google a command for Linux and you're having trouble with, chances are you're going to wind up on a web page that's just the man page. And so all of that stuff is in front of you at your fingertips all the time without an internet connection. So I do suggest spend some time learning how to navigate the man pages and find that information that you're looking for. So for example, how did I find out that minus NRK3 is what I would use for PS? Man, right? Man space PS. And there you're going to have the options to go ahead and figure out how to build up that complicated sequence to answer that question. If you're using PowerShell, you certainly have PowerShell help with get help. Now, on Red Hat based systems, there's this concept of local documentation. Anything that you install on Red Hat based systems is going to it's going to put its default documentation for that particular package and stick it in USR shared doc. So if I go and I look in USR shared doc, I'll see a subdirectory for nearly every package that's installed on my system. Inside that directory, let's say it's Apache or HTTP, I go and I change into that directory and I'm going to find example configuration files. I'm going to find default configuration files, README files, and things like that. So if I bonk up my default configuration, I could go there and chances are there's a copy of the default configuration available to me there. Or if I need to do something more advanced, again, like if I'm using Apache and I need to set up a virtual server, those examples live in that location. Again, at your fingertips without an internet connection. So the key takeaways today, guys, are Linux is just an operating system. Once we get over that syntax and those environmental changes, think of different shells and different file locations and things like that, a lot of the concepts are really the same, right? We have the architecture of kernel mode and user mode certainly exists in Windows. IO redirection and text-based pipelines, again, something that you guys are used to entirely with object-based pipelines. We talked about file system basics, how to use PowerShell on Linux, how to install packages and get things off of repositories. We looked at System D, how to start and stop services, and again, and some basic system resource management. So, some additional resources for you guys. Here are 3 Pluralsight courses that I think apply to what we've covered today, with many, many more hours of what to cover. The first one basically takes you from sticking the DVD in your server for the first time all the way up to executing commands, managing files, dealing with permissions, using VI. If you're scared of using VI, good demos there for that. And also some advanced shell topics and more coverage of pipelines. If you're into managing performance and system services and things like that, check out Advanced Network and System Administration. Again, if you want access to these things, I can just shoot me an email and I'll give you a free 30-day card. And that last course there is the training video I did with Jeffrey Snover and Jason Helmick when PowerShell Core was released back in 2016. So if you need any more information, there's my email, Twitter, and things like that. If you want to go ahead and discuss any questions, I think now might be the time. Are you there, James? Okay, I was getting a little nervous. Like, did I just present for an hour and uh, I got to. Well, my computer didn't catch on fire. Well, cool. Here, like I said, my email and my Twitter account is on the screen. So if you do have a follow up question and you want to reach out to me, go ahead and do that. But James, I appreciate you having me in the Chattanooga group. I'm gonna go eat some pizza myself now because you guys had some. Yeah, I'll shoot you a DM in a few minutes here. I'm gonna stop it now.